Here are the answers for the section 15-5 homework. In the first questions, we're asked to find the inverse, and these are 2x2 matrices. So to find the inverse of the 2x2 matrix, we're going to use a formula. It involves doing 1 over the determinant. So now let's find the determinant. 1 times 1 is 1, minus 2 times 3, which is 6. 1 minus 6 is negative 5. And that determinant value goes in the denominator of a fraction. Now multiply by a 2x2 matrix. And to make the entries, we're going to use these four numbers. You switch the positions of the top left and bottom right, but they're both ones, so they stay as ones. And then this number and this number, you change their signs. So this is negative 3 and negative 2. What's left to do is to distribute that negative 1/5 to all four entries. So that will make negative 1/5, and then 3/5, 2/5, and negative 1/5. This 2x2 matrix is the inverse of this original matrix. If we were to multiply them together, we would get the answer 1, 0, 0, 1. This next one, to find the inverse, you go 1 over the determinant. So let's find the determinant. 1 times 3 is 3, minus negative 2. 3 minus negative 2 is 5. And then we're going to make a matrix with four numbers in it by switching these two. So 3 and 1, and then changing the sign on these two. Negative 2 and positive 1. Now distribute the 1/5 to all four entries. So 3/5, negative 2/5, 1/5, and 1/5. This right here is the inverse of this original matrix. Next one, we're going to go 1 over the determinant. So 4 minus 4, and that makes 0. As soon as I see that the determinant is 0, I'm not even going to take the time to finish out the process, because there's no way 0 can be the denominator of a fraction. This one has no inverse. Number 7, 1 over the determinant. 4 times 1 is 4, minus 0. That makes a 4. And then in the matrix, switch the 1 and the 4, and change the sign on the 5 and the 0. But negative 0 is still 0. Now distribute the 1/4. So this is 1/4, negative 5/4, 0, and 1. Number 9, to get the inverse, 1 over the determinant. Negative 4 minus negative 6. And that makes 2. Now the matrix portion of this. Switch these two numbers. So the 4 here, the negative 1 here. Change the sign of the other numbers. Negative 3 here, positive 2 here. Now distribute the 1/2. So 2, negative 3/2, 1, and 1/2. And number 11, same thing. 1 over the determinant. Negative 1 times negative 2 makes 2, minus, in this direction is 3, so 2 minus 3 is negative 1. The negative 2 goes here, the negative 1 goes here. This becomes negative 3, this becomes negative 1. Now 1 over negative 1 is just negative 1, so let's distribute that to all four entries. This becomes 2, 3, 1, 1. In number 13, we're asked to solve a matrix equation. The capital A is some unknown matrix. In front of it, it's being multiplied by another matrix of numbers called the coefficient matrix. We want to remove this coefficient matrix by multiplying by its inverse. So first we need to find its inverse. And I'm going to do that just in the margin space over here on the left. 1 over the determinant. So 1 times 3 is 3, minus 2. And that makes a 1. And then let's go through the step of working with these entries. 3 here, 1 here, -2 here, and -1 here. By the way, 1 over 1 is just 1, and when you distribute that to these numbers, you're just going to get those same 4 numbers. Okay, now that we know what the inverse is, we want to multiply by that matrix on both sides of the equation. We want to multiply right there in front of this one, and right here in this blank space that I had left. What we're doing is multiplying by the same thing on both sides of this equation. On the left side, when you multiply this coefficient matrix by its inverse, it cancels away and you get the letter A alone. And on the right side, we need to perform a matrix multiplication. 3 times 0 is 0, plus -2 times -1 makes 2. 3 times 1 is 3, plus -2 times 2, which is -4, so this is -1. Now let's do the bottom row. -1 times 0 is 0, plus -1 times -1 is +1. -1 times 1 is -1, plus 1 times 2, which is 2. So -1 plus 2 is 1. And this matrix is matrix A. Now number 15, let's use the same technique. We can remove the coefficient matrix in front of matrix A by multiplying by its inverse. So I'm going to go over here in the margin space and find its inverse. 1 over its determinant. 3 times 2 is 6, minus 2 times 2, which is 4, so that makes it 2. Now let's manipulate the entries. 2 here, 3 here, -2, -2. Let's multiply 1/2 to all of those numbers. This is what we're going to get. 1, -1, -1, and 3/2. Here is the inverse matrix of that coefficient matrix. And we want to multiply that in front of this matrix and in front of the matrix on the other side. And I'm going to show that in this blank space. When you multiply this inverse by this original matrix, it cancels away and the letter A is alone. On the right side, we're going to get a 2 by 2 matrix. Let's run through the multiplication. 1 times 5 is 5, plus -1 times -1. And this turns out to be 6. 1 times 0 is 0, plus -1 times -1. This turns out to be a 1. Now the bottom row. -1 times 5 is -5, plus 3 times -1, which is -1.5. So this is -6.5. -1 times 0 is 0, plus 3/2 times -1, which is -3/2. Here is matrix A. Now number 17. We still have a matrix equation. It has a matrix multiplied to A and a matrix subtracted from A. Let's first add that matrix to both sides of the equation. Notice how similar this is to equations that we solved earlier this year that involved real numbers. By adding the matrix, it causes this to cancel away. And now we have this portion alone on the left side of the equals. On the right side of the equals, we want to add these together. So let's do the top left entry. 1 plus 1 is 2. Now the top right, 5. Now the bottom left, 1. And the bottom right, 4. Notice how I've left that blank space in here because I know what's coming next. I know I'm going to multiply a matrix to the left side of this one. Now what is that matrix? It's going to be the inverse of this. So over here in the margin space, let's find that inverse. 1 over the determinant. 5 times 2 is 10, minus 3 times 3, which is 9. So that makes a 1. And now let's work with the 4 entries. Switch the 2 and the 5, and change the signs on those 3's. 1 over 1 is just 1, and 1 times those 4 numbers is those same 4 numbers. Now we're taking that and multiplying it right in front right here, but you notice I haven't really taken the time to show that work step. And on the right side of the equals, we're multiplying that matrix. On the left side, we get the letter A alone. And on the right side, we're going to get a 2 by 2 matrix. We just need to do the multiplication. 2 times 2 is 4, plus negative 3 times 1. This makes 1. 2 times 5 is 10, plus negative 3 times 4, which is negative 12. 10 and negative 12 is negative 2. Now the bottom row. Negative 3 times 2 is negative 6, plus 5 times 1, which is 5. So that makes negative 1. Negative 3 times 5 is negative 15, plus 5 times 4, which is 20. Negative 15 and 20 makes 5. Here's matrix A. Now the review assignment. We're going back to page 562, and this is where we were first learning to find the determinant, which was a step in finding the inverse. So we've already done this in today's assignment. To get the determinant, you multiply this diagonal. 0 times 1, that makes 0. And then subtract this diagonal, which is 2. And so the answer is negative 2. Now number 10 is a 3 by 3 matrix. And there's more than one way to find the determinant. But the way that we have studied is to copy down the first column again and the second column again. Then we're going to multiply diagonally, just like you do with the 2 by 2. The first diagonal we're multiplying is the 8 times the negative 1 times the 2. And that makes negative 16. Then add and do this next diagonal. 1 times the 4 times the 1. That's 4. Now add again and do this next diagonal. 3 times 2 times negative 1. And that's a negative 6. Now that's all of the diagonals that start in the upper left and go downward to the right. Now we're going to subtract our upward diagonals. The 1 times the negative 1 times the 3, which is negative 3. And then subtract again. Negative 1 times the 4 times the 8. That's negative 32. Then subtract. And then the 2 times the 2 times the 1. That's a 4. So we're doing this diagonal, this diagonal, this diagonal, and adding those together. And then we're going to start subtracting this diagonal, and this diagonal. Once you've written out all the pieces, just grab a calculator and type that in. I get 13. Assuming I typed that in correctly. Now we're going back to page 559, and this is where we were learning to multiply matrices, which again was one of the steps in today's assignment. So we've already multiplied some matrices. Now these are 3 by 3s, not 2 by 2s, so it does take a little more effort, but the method is the same. So we're going to get a 3 by 3 matrix for the answer. And you figure out each of the 9 numbers by using numbers from the rows and the columns. So to get the top left number, you're going to use the first row and the first column. You're doing some multiplying and adding, So negative 2 times negative 3 is 6, plus 1 times 1, now we have 7, plus 0 times negative 1, and that makes us 7. Now let's do the top middle. So use the top row and the middle column. So negative 2 times 0 is 0, plus 1 times 2, so now we have 2, plus 0 times 1, and that makes it 2. Now the top right. To get the top right, you're using this first row and this third column. Negative 2 times 1 is negative 2, plus 1 times negative 1, so now we're negative 3, plus 0 times 3, and so this is negative 3. Now we're ready to do the middle row. So we're going to use the middle row and then each of the columns. So 0 times negative 3 is 0, plus 1 times 1, so we're at 1, plus 1 times negative 1, and that turns out to be 0. 0 times 0 is 0, plus 1 times 2 is 2, plus 1 times 1, so this makes 3. 0 times 1 is 0, plus 1 times negative 1 is negative 1, plus 1 times 3, which is 3. So negative 1 plus 3 makes 2. Now we're going to do the bottom row. So you use this bottom row and the 3 columns. So negative 1 times negative 3 is 3, plus 2 times 1, so now we're at 5, plus negative 1, so it's 4. Negative 1 times 0 is 0, plus 2 times 2 is 4, plus 1 times 1. So this makes 5. To get that very last number, you're using the bottom row and this last column. Negative 1 times 1 is negative 1, plus negative 2, so we're at negative 3, plus 3. And so this makes 0. Now number 8 has exactly the same problem. It's a 3 by 3 times a 3 by 3. And so the answer is a 3 by 3. We just need to run through the process. 1 times a is a, plus 0 plus 0. This makes a. 1 times b is b, plus 0 plus 0. So this is b. 1 times c is c, plus 0 plus 0. So this is c. Now let's go across the middle row. 0 times a is 0, plus 2 times d is 2d, plus 0. So this makes 2d. 0 times b is 0, 2 times e is 2e, and then 0h. So this makes 2e. And I think this is going to make 2f. Now the last row. 0 times a is 0, 0 times d is 0, and 1 times g is g. Now let's work in the middle. 0 times b is 0, 0 times e is 0, and 1 times h is h. I think I see the pattern. This is going to be I.